record. Okay, so yeah, just imagine that nothing is being recorded or whatever, just yeah, as per usual. Right, so there's nothing new after our lesson, meaning to say last week we had covered a bit of redox, we had covered a bit of rate of reaction, we had covered a bit of was it transfer of thermal energy, or was it more of KPT for physics, or was it energy work power?
Yeah, energy work power.
Okay, so today, do you want to continue on with the redox since we are on that?
Yeah, sure.
Yeah. Okay, so this is the thing, yeah. From now to 7:15, we probably can only cover a little bit of the redox stuff. Yeah, and then obviously we go for Booker, and then when we come back, we continue on. So for clarity's sake, I think let us just stick to one chemistry topic and one physics topic for today.
Okay.
Okay, would you want to just focus on redox and kind of like just make sure that you can do like not only the easier questions but also the slightly harder questions?
Yeah.
Just focus on redox. Yeah, even though redox, yeah, by right in the syllabus is actually a small section of the larger topic. The topic in chemistry in which redox is in is called chemical energetics, right? So it includes the whole thing about endothermic, exothermic reactions, rate of reaction, and redox, right? All that comes under chemical energetics. So today we focus more on redox, and yeah, is that okay with you?
Yep.
Okay, and then for physics it's just KPT, yeah. Okay, I think let us just start with KPT first. Yeah, since the Abdullah is not in, I will just take you through. Right, so for this topic, yeah, on theory, I know that in chemistry they have a very similar topic, right? But it's called particulate nature of matter, right? And actually the content points is very similar, right? But the focus in chemistry and in physics, there's a very slight and a very nuanced difference between the two. Yeah. So for this one, let me just share my screen so that you're able to see. Okay, give me a short while. Okay, I'm going to show you the SEAB syllabus again. This is the must-know document in which everything that is relevant for your exams is reflected in this. Okay. So as you can see, you're able to see, right?
Yeah.
Just zoom. Right. So under physics, should be this one, sorry. Yes, okay. This is the physics section of your syllabus. Yeah, kinetic particle theory is actually the first chapter before all the other topics relevant to thermal physics. Yeah, so under kinetic particle model of matter is a very, very simple topic really, but what is important is knowing how to explain. And there's this new phrasing, okay, to do with energy, new to this current syllabus. It's called internal energy, okay, which I believe you had gone through already. So firstly, we know how to compare the physical properties of solids, liquids, and gases. And then we need to use kinetic particle theory to describe different states of matter, solid, liquids, and gases, and relating it to their physical properties to the arrangement and motion of particles. This one is the key part. We need to be very, very clear how to describe and explain the arrangement and the motion of particles. Okay, and the forces and distance between the particles. Okay.
Wait,
Hold
sorry,
on.
are you like, is the screen on something?
Can you see my screen?
It's
Because I'm
on,
sharing.
I don't think I can see it.
Because I'm sharing it on the Zoom, sorry, not the Zoom, the Google Meet itself. Do you see?
Oh yeah.
Yeah, so it's on the meeting itself. Okay, Abdillah, I'm just running through some stuff with Najiha for a while. Abdillah, I've actually pre-recorded some videos here for especially forces. And then today I want you to kind of start on transfer of heat actually. So Abdillah, if you can turn on your video and your audio, and actually in 5 minutes time we'll kind of take a break anyway because of Buka time. Okay, so Abdullah, I want you to just warm up first. Yeah, if you can. Yeah, I want you to warm up first in the sense of take out your assessment book and your science textbook, look through forces. I will very quickly wrap that up for today and then we move on to transfer of heat. Okay, Najat, let us very quickly go back again. I believe I need to share this one other document. Yeah, can you see? You should be able to see now.
Yeah.
Yeah, okay, sorry. I think I might have shared a slightly different document just now. But anyway, yes, as you can see, yeah, these are the different learning outcomes. Compare the physical properties of solids, liquids, and gases. Use kinetic particle model to describe the different states of matter, relating their physical properties to the arrangement and motion of particles and the forces and distances between the particles. So in physics, we are focused more on, for example, the intermolecular forces of attraction, okay, and the fact that between these particles, okay, the distances might be short or they might be very far apart depending on the state, okay. And then here, relate the rise in temperature of a body to the increase in average kinetic energy of all the particles in the body, okay. So we always associate temperature to be about heat energy, right, and temperature about how hot and how cold. But now at upper sec level, we have to actually make the link. Temperature is not necessarily about that, but it's about the amount of kinetic energy, right? Because in kinetic particle theory, it states that all matter, all particles, they are in constant random motion, whether they are vibrating in their fixed position or moving freely within the liquid or moving in all directions in a gas, in a volume. Okay, so very important. In physics, relate temperature or the rise in temperature to the increase in average kinetic energy of the particles in the body. Okay, and then this next thing over here about the internal energy. Okay, it is the energy store that is made up of the total kinetic energy associated with the random motion of the particles and the total potential energy between the particles in the system. So it's not only just about the kinetic energy, but kinetic energy and the total potential energy. Ken?
Mm-hmm.
Okay, and then here we have the next portion here. Describe melting or solidification and boiling / condensation as processes of energy transfer without a change in temperature. So this one has to do with, in our heating curve or cooling curve, there's always these two sections where it's flat. There is no rise in temperature, right? And the reason why that is flat is because any energy that is being absorbed is needed to overcome the intermolecular forces of attraction in order for it to either melt or boil, right? And in the opposite case, in the cooling curve, whatever energy that is being released, okay, something about the forces, the particles getting closer together. Okay, so this is basically it for the kinetic particle model of matter. Later on, after Booker, I'm going to get you to read just a little bit further, okay, and then I will get you to try out the questions. This particular chapter, right, the difficult questions is not the difficult questions is actually the structured questions because they're going to be very particular with how you answer. Can? Okay, Zuhair is in. I'm just going to admit everyone because we have like 2 minutes before I'll give you all some time during Booker time. I will explain what is going on. Okay, so Abdillah, I've already pre-recorded videos for forces and I should have the transfer of thermal energy ready for you. Okay, so after Booker, when we return back, right, I'm going to send you the videos for you to watch, and then after that I will assign questions for you to do. Okay, Zuhair, for you, you just come in, it's okay. Let me just explain to you what's going to happen during
Okay.
our online lessons, okay? So, Zuhair, for today, I think, shall we focus on respiration a little bit more to just practice your answering skills? And then I believe your
Okay.
bio teacher has started on infections, right?
Yeah.
How are you with infections? So far, understand?
Uh, yeah.
So far, understand. Okay. So, I know that it might be a bit much, so we'll just see first. But I definitely want you to polish up on your respiration topic, can, for
Okay.
today. If we have a bit more time, if you feel that you're okay, understand. If you have a bit more time to spare for bio, maybe we can take a look at infections. But priority is on respiration. Okay. And then, Azrael, for you for chemistry, are you still on the metals chapter?
Qualitative analysis.
Your teacher is moving very fast, yeah, because last week you were just doing on metals, I believe, right?
Yeah.
Okay, so what is it that you want to focus on then for today for chemistry?
Uh,
QA or
Qualitative analysis.
metals?
QA.
QA. Your metals, you're fine?
Yeah.
Okay, can. Right, so everyone basically knows what you're going to do, yeah? So when we are done with book break, Najiha, I will get you to, yeah, read on further PPT, do questions, and then for chemistry, redocs, okay? I've already prepared the stuff already. And then Abdullah, I just said, okay, and then Zuhair for you, yeah. Priority is respiration, if there's time, infections, if not just respiration, and then QA, can? Okay, now guys, I think for our convenience, we don't have to leave the meeting. Are you okay to maybe just mute yourself and turn off video?
Mm-hmm.
Then once we are ready, we just come back in so you don't have to like log in, blah, blah, blah. Is that okay with you all?
Okay.
Okay, can ya? Okay, I'm going to mute myself. So guys, I'll give you 20 minutes, but to be honest also, if you all come back at 7:40, 45 also can lah. Okay, we'll just end whatever time we start, can? I'll be back by 7:35 to just stand by for everyone, okay? Okay, have a good book break, bye guys, everyone. So that exchange of gases can happen, right? Because the alveoli, remember, is a tiny, tiny air sacs that is inside the lungs, right? And as we know, when we breathe in air, we are trying to take in oxygen from the air that we breathe, right? And when we breathe out, we are trying to remove the carbon dioxide that is being produced from aerobic respiration, and remove it from the body because carbon dioxide is a waste product. So far, you understand that point?
Yeah.
And okay, so then why this whole thing about the adaptations for the alveoli? Remember, anything to do with by the way, are you able to see my screen? I know it looks a bit
Yeah.
weird, right? Trying to pull out a whiteboard. Are you able to see a whiteboard right now?
No.
Do you see a whiteboard right now?
No.
Let me try again. Okay, you should see an infinity thing. And you should see a whiteboard. Can you see my whiteboard?
No.
No? Let me try again. Okay, you should be able to see a whiteboard now.
Yeah.
Okay, can. Right. So, like what I was saying, yes. Why do we have to understand about the adaptations of the alveoli? Because it's very critical, especially when we're talking about the exchange of gases. Okay, so alveoli are the tiny air sacs that line our lungs. Okay, and all these tiny alveoli is where the gaseous exchange happens. Yeah. So when we breathe in air, you can just imagine, okay, air going in here. The air that we breathe will contain oxygen, obviously, right? And the whole purpose of this gaseous exchange is to, okay, always remember that we are talking about blood also. We are talking about exchange of gases. What are these things that I'm drawing, Zoe, by the way? What are these things I'm drawing?
Blood cells.
Specifically?
Red blood cells.
Yeah. And what do the red blood cells carry?
Oxygen.
Okay, so the oxygen that we breathe in, they would need to diffuse through the walls of the alveoli and through the walls of the blood capillary to get to the red blood cell, right?
Yeah.
Correct? And then what about for the carbon dioxide? The carbon dioxide is not carried in the hemoglobin, it's actually carried in the plasma as hydrogen carbonate. It will also diffuse out of the capillary and into the walls of the, through the walls of the alveoli to get into the alveoli capillary. Understand?
Yeah.
So that the air that we breathe out, okay, will carry the carbon dioxide out. So again, what did you say again, that there's a thin film of moisture? What is the purpose of the thin film of moisture?
So so the oxygen can dissolve.
So that the oxygen will dissolve in the thin film of moisture, and then the water containing the oxygen will then diffuse, right, into the into the blood capillary. You understand? So
Yeah.
this here will be the direction of blood flow. So whenever you have questions like this, it's pretty easy to understand. Before the gaseous exchange, this region over here, the blood would contain less oxygen and more carbon dioxide, right? As the blood flows and it comes into contact with the alveoli and the gaseous exchange happen, the green region here, the blood content will have more oxygen and less carbon.
Dioxide.
Yeah. Okay. So this part here is about the gaseous exchange. Okay. Anything else other than the gaseous exchange that was run through, that was discussed in the video?
The what is it? I forgot.
Which one? Try to
The one after. There was one part after that.
Did I talk about the sorry, did I talk about the oxygen debt?
Oh yeah.
Okay, what about the oxygen debt?
But as the person exercises, the
Mm-hmm.
the oxygen needed is more, and then when there is when when oxygen demand cannot be met, there will be a oxygen that
Yeah,
there'll
there'll
be a
be an
deficit.
okay. So this thing about the oxygen that you need to be very careful. Yeah, as a person exercises, the demand for oxygen increases, right? Because why? More oxygen is needed for a higher rate of aerobic respiration, right? In order to release more energy. Does that make sense?
Yeah.
Okay. However, there will be a certain point in which the body is unable to bring in more oxygen, and that is simply because there is a limit to how fast we can breathe, right? And therefore, how much oxygen can be absorbed. You understand?
Yeah.
So you have to understand there is a limit. There is a limit to the volume, okay, of oxygen that can be breathed in. Understand? And therefore,
Yeah.
there's a limit to the volume of oxygen that can be absorbed by the body. And therefore, there's a limit to the amount of energy that can be released via aerobic respiration. That is where what process kicks in? And
Anaerobic respiration.
anaerobic respiration. Understand?
Mm.
Can? Okay. So when anaerobic respiration occurs, what are the byproducts of anaerobic respiration? One of them being
Lactic acid.
lactic acid. So lactic acid will be accumulated in our muscles, right? As anaerobic respiration kicks in to just supply the body with a little bit more energy. Understand?
Mhm.
So the amount of lactic energy is actually an indication of how much oxygen debt that we are incurring. Debt means how much we owe, right? It's referring to like how much we owe, but it's not really how much oxygen we owe. It's the amount of oxygen that we needed to have. It reflects the amount of oxygen that we needed to have to supply the body with the required energy, right? So we need to pay off, in a way, we need to pay off this oxygen debt even after we have exercised. That is why the heart rate, the breathing rate remains quite high even after exercise because our body needs to breathe in more energy
Oxygen.
because oxygen is required to,
Remove the lactic acid.
yes, remove the lactic acid from the body. Can you?
Yeah.
Okay. Next thing, anything else from this video?
I don't think so.
Okay. So now can you check with your assessment book now? Okay. Can you now tell me how many specifically short answer questions? I think it should be quite a few that you can try out.
Like 4
Structured questions, is it?
structured.
The short answer questions.
The MCQ or
The short. Meaning to say is the section after the MCQs. Because I want you to practice the answering skills
one?
for the short response. I think that's what it's called in this book, short response.
Yeah, there's 4.
Yeah, okay, there's 4, right?
Yeah.
Okay, so the first one, I'm looking at it. It is the experimental setup, right, with the cricket and the gauze and the glass tubing, right?
Yeah.
Okay, I want you to try that one. And then linking to what we had discussed, I also want you to try out the next question. So can you try out these two questions first? Do write down your answers on foolscap paper.
Okay.
Okay. I'll give you some time to try it out.